Okay, this next section here, we finished up talking about on Monday the non-specific defenses, the first line of defense and the second line of defense, which included the inflammatory response. So today what we want to do is go through the steps of the specific response, as well as how we create and use vaccinations. So the specific response is, obviously by its name, is a very specific type of protection against certain types of invading bacteria or antigens that may enter the body. Now the key components here are antigens and antibodies, and we talked about these with the blood system, or the blood, so these terms should be familiar. Antigens are what actually trigger the response of this system. And remember, these are the substances that are on the surface of the pathogen or the cell that are coming in. And these are recognized as foreign because the proteins on those cells or on those pathogens, those antigens, don't match that of the person. And this is what creates the problem when people have organ rejections. When you have a transplanted organ, the organ itself might function, but the cells, because they come from somebody else, those antigens don't match the person who's receiving them. So what happens is the person who's receiving it actually treats it, their immune system treats that like a foreign object, and it actually tries to go and attack it. So people who receive organ transplants actually have to go on anti-rejection medicine, which kind of suppresses their immune system. Now, this can decrease the longevity of that organ and can also make them hypersensitive to other things. Obviously, because their immune system is compromised due to these drugs, when they get sick, they also have to really make sure that they consult with their doctors when they get sick at all, because they have to monitor that very, very carefully. Now, antibodies themselves are protein compounds that are normally present in the body, and they are Y-shaped, and at the end of the arms of the Y are these concave regions called combining sites, and they attach to the pathogen like the lock and key mechanism of an enzyme and a substrate. The shape of the combining site has to match the shape of the antigen, and that's how it works. So because of that, this system is what we call specific. One antibody matches up to one specific type of antigen. Now, the antibodies themselves are made through the actions of the T cells and the B cells, which are types of white blood cells. What the antibodies do is basically two things. One of them is that they mark, they kind of flag those pathogens for destruction by the phagocytes, or they can also, just by combining with the antigens, render that pathogen completely useless, and eventually it'll get cleaned up by the phagocytes. So it's kind of this dual action that's going on. Now, in order for this specific response to take place, a pathogen actually has to get past all of our non-specific defenses and into the body in order to produce our antibodies. The more antibodies a body has or a person has, the better the protection they will have. Now, when we first are exposed to something, it does take us about 7 to 10 days to make our antibodies, and then we start actually kind of getting over being sick. The second time around, though, we get a much quicker response because we have antibodies that stay in the blood, in addition to memory cells, which work to kind of remember that particular type of infection. Now, what happens is, you may get sick, like get a cold twice, but the thing is that cold virus has changed or mutated between the first time you got it to the second time you got it, and so the antigens on that virus have actually changed, and that's why you get sick twice. You won't get sick from the exact same thing, though, 2 times in a row. Now, the exposure that we get can happen in a couple of ways. It can be inborn, so then we're actually exposed as a fetus through mom, or acquired. And acquired can be done in 2 different ways: artificially through the use of vaccines that we'll talk about in a minute, or natural through actual exposure. People actually, like with chickenpox, if a kid would get chickenpox in a neighborhood, sometimes the moms in the neighborhood would actually take their kids over to that kid's house and expose their children to the chickenpox virus, so they would actually come down and get sick with it. So that's kind of what we're talking about here. Now, the natural immunity that we have can either be described as passive or active. Passive immunity are when we get antibodies that are prescribed by a doctor.
Please excuse the interruption.
Sorry about that. An example of this would be like with a snake bite. We don't actually produce the antibodies that will help fight the venom in a snake bite, but a doctor can actually give us those antibodies. Active immunity are when your body produces the antibodies all on its own. So passive immunity can be borrowed from another organism, but it is short-lived. It's not permanent. So, for example, antibodies injected to combat a specific disease that our body won't produce, or like some of the antibodies we get from mom as a result of pregnancy, and we can also continue that through breastfeeding. Active immunity also includes immunity that's produced by vaccination. So vaccinations are an active, artificial type of immunity. And a vaccination is where we inject either weakened or killed or even just pieces and parts of a particular pathogen. What happens when we do this is the body produces its own antibodies and remembers that disease. So let's quickly here go through the preparation and use of a vaccine. The first thing we got to do is obtain the pathogen. Now this sounds really simple, sometimes it's not all that simple. Viruses are really small, they can actually be very difficult to isolate, and especially with some of our early diseases, we didn't have the technology available to isolate them as easily. Once we obtain the pathogen, we also have to grow enough of that, and most of the big vaccine companies actually use chicken eggs to grow large quantities of the pathogen that they need because they're cheap and they're really easy to use for them, because then they need to use those to create the vaccine. And if you ever get a vaccine, you actually sign this thing that, and one of the warnings is on the consent form is, that you shouldn't have this particular shot for most of them if you're allergic to chicken eggs, and that's why. We then treat the pathogen either with heat or with chemicals to either kill it or weaken it. And once we've altered it like that, it is now called a vaccine, and it gets injected into the organism, whether it's us or say our dog or our cat. The body then responds to the antigens that are present, and they make antibodies, and they actually go and they attack the invaders. Now the whole idea of the vaccine is that we're kind of stacking the deck in favor of the body. Because the pathogen is weakened or killed, it should not get us sick, although that is still a possibility. Again, if you read any of the side effects, one of the possible side effects with any vaccine is that you'll actually get the disease itself. The last step is that some of the white blood cells that are specific for this pathogen actually stay in the body and they continue the protection. Now sometimes the body needs a little bit of reminding about this, and that's why we get those booster shots like with our tetanus shot. Okay, in the next segment I'll finish up with allergies and autoimmune diseases.